Okay, this time we're talking a little bit more about the hazards that you all encounter as pilots. You've learned a lot of the basics of meteorology here in the last several weeks, so we're going to talk about applying them to hazards that you actually see and maybe how to deal with them. So I thought I might focus down towards Florida a little bit today. Uh, this is an experimental weather map produced by the Aviation Weather Center. It has lots and lots of information on it. Here are some convective outlooks down here. You can see an off the shore here. You can see turbulence. You can see aircraft reports out over the water here, where they're flying at lower, different altitudes down here as well. Big shift here between Jacksonville and Tallahassee, where there's a cold front passing here. Some of the hazards we're talking about are wind shear. So if you just look at this, first off, anytime you're around convection, you're going to have some wind shear hazards. So we can see a convective outlook here, here. Obviously, there's some convection going on over the Gulf of Mexico. So that means there's wind shear around those areas immediately. There's some off the coast here. So if I am flying today from Philly or New York City, probably down to San Juan, we'll say, I'm probably along this flight path here. And yes, most of the time at 35,000, 39,000 feet, I'm above a lot of the thunderstorms that are over the ocean. But there are once in a while, you're going to get some that are a little bit higher. Now, over land, that's a whole different ballgame. Thunderstorm tops over land can reach 50,000 feet or more. You're not going to fly over them. So it was interesting to look. The book had a chart of a thunderstorm. So say you were flying, had a thunderstorm near the airport you are. Well, first, out ahead of the thunderstorm, we know warm air rises. Well, warm air is the feeder for the thunderstorm. So it's going to be coming in out ahead of the storm. There's going to be a low deck of clouds out ahead of the main rain shield. Somewhere in here is the main rain shield. That main rain shield is going to contain a downdraft. Remember, rain is going to condense more and more. It's going to cool the air there. When it cools the air, it actually gets more stable. So you wind up having air moving downward, accelerating towards the ground. That's why you get the downburst. You can't go anywhere when it hits the ground. So it's just going to go out in both directions. So you have one section of the storm. If you were to, for some reason, fly into or around the storm, you're going to have an area of cloud of updraft coming in. And yeah, interestingly, you can look at a storm. Say you were to the south of this storm, looking at it to the north of you. You probably notice this layer of clouds, especially if you're flying. You can see the area of clouds out ahead of it, and then a cut down to the bottom of it, and this rain shaft in it. Look at that rain shaft. The more it goes out on each side, the stronger the winds are in that rain shaft. Or if you see it tilted to one way or another, that's a great indication that there is some extremely strong winds there. You have a great visualization viewpoint being in an airplane. You're looking at this from above. So if you don't have clouds around you, you're seeing all of this with this thunderstorm. So you can anticipate where, if for some dumb reason you're being routed near this thunderstorm, you can understand what kind of airflow you have. You're going to have the air coming up here on the shelf cloud, down on the outflow. So these are things when you're flying around and have an individual thunderstorm, and there are many times of the year you can see this. However, there are other times when you have multiple thunderstorms, and you can actually look when you're flying into that area and maybe see different towers. I notice I'm always looking at the weather when I'm in an airplane. Yes, I'm not the pilot, so I get to look maybe a little more. But I can see these towers, maybe to my left or to my right, where the pilot's trying to weave his way through. Part of me wants to see under the airplane as well, but I want to know if something's rising between those two towers. Say I have this wind coming down, this big gust front here. Say this gust front eventually, depending on what the wind shear is at all, it might get out here well out ahead of that updraft. Maybe it is going to push another area of clouds, start down here low and go up. Now, let's say I have another thunderstorm over here that has a downdraft coming down. Where these two downdrafts meet, I'm going to get a new area of convection. A new thunderstorm is going to develop between the two old ones. This is prevalent in the summertime. This is something to be aware of. Yeah, your radar may pick up an area of not much happening in here, but be aware that if the outflow from the two storms is hitting each other, maybe there could be something developing underneath you. So just something to look at when you're just looking at thunderstorms and the towers that you see out there. There are microbursts, and we talk about the little cylinder around them with a vortex ring. Well, guess what? There's vortex rings all the time out there in what you're flying through. Have you ever flown across the Midwest and see a line of clouds, nothing, another line of clouds, nothing? These are not tall clouds. They may only be 15,000 feet in height, maybe not even that. But what they are is literally rings, vortex rings like this, that have developed across the Midwest, maybe from a west wind, and they'll go up for a little bit where your clouds are, then they're back down, then you'll back up again. And they're literally doing that. And you'll be able to anticipate where you're going to have a vertical updraft and where you're going to have a downdraft between them. So if you in a small plane flying along, you'll be able to spot these kind of clouds occurring. So I wanted to move along. I mean, there's a lot in here about thunderstorms and all. Over the Midwest and West, sometimes you get virga storms, especially in the desert Southwest. And these can really have tremendous winds down to the ground, push a lot of dust out with no precip reaching the ground. Okay, fronts. We know that on a cold front moving into your area, and let's take a look back at this picture here a minute. So if I am flying into Tallahassee right now, I know down in Tallahassee at the moment, the air is coming out of the northwest. However, how steep is that cold front? Well, let's just take a peek at this cold front a minute. So this is a sounding from this morning for Atlanta. You'd think, man, this cold front well south of Atlanta, this air mass is going to be pretty thick, right? Well, the reality is it's not so thick. Yeah, you have some pretty strong northerly winds here. 30 knots out of the north, below 5,000 feet. All of a sudden, above 5,000 feet, however, you go west and southwest. You're in the warm air again, literally. So you have wind shear. This front is not that thick. So your front literally has sloped from Tallahassee to 5,000 feet thick all the way back at Atlanta. Think about that slope and how it's risen up. So if you were flying across Georgia today, you could, in a small plane, we'll say, and flying at a low elevation, you would literally be crossing into the warm sector at some point. Winds would go from the north to the west, and that can impact your performance of your aircraft with wind shear. So that is one aspect I wanted to look at today, and I just, there you can see a demonstration of this in real time. Another time it can occur, think about it if you have a strong low pressure system. This is a nor'easter they're talking about here. Say you had the same low in the Midwest. out ahead of the nor'easter, you're probably going to have, particularly over eastern U.S. where you have an ocean out here, get warmer air, literally not warm air, but warmer coming in off the water here. Warm air, moist air coming up from the south. That warm air is lifted. There is a lab I gave you where you literally have ceilings down here in Virginia and Dulles that are around 500 feet, 400 feet. You're on the north side. You're in the cool air. If you look at it, your winds are probably out of the east. All of a sudden, you go into the warm air. The warm front has got north of you. Now you have southerly winds. Those low clouds are going to dissipate. You're going to start getting some much better conditions. Yeah, the warm air is now north of you. Warm front is north of you. So the low deck of cold air that was keeping you socked in the low IFR, LIFR even maybe. And it happens along the east side of the mountains many times, either here or you can have it literally in the Denver area and all there as well. So you can see how these understanding that you're going to get a wind shear along that front. If you were flying out of Dulles that day and you would be having northeast winds, say, and all of a sudden, if you were flying to the south, you literally on takeoff, you would be flying above into the warm air and your winds would shift probably to southerly. And I have seen times where there's 70 and 80 knot southerly winds at 1,000 feet off the surface. So I hope you're anticipating that when you're lifting off to a north wind. So you're taking off towards that north wind and you're all of a sudden going to shift and have a southerly wind, a tailwind of 60 and 70 knots, maybe at 1 to 2,000 feet off the ground. So all this has been talking about wind shear, and there is always going to be wind shear out there. And stability is a way of thinking about getting rid of the wind shear in some ways. But when you're changing from a stable layer to an unstable layer, you're probably going to shift in your winds. And your wind speed will probably pick up as well. The next area we're talking about is turbulence. Turbulence is right there with the winds, obviously. But there are all kinds of turbulence, and depending on the aircraft you're flying, that turbulence is going to change. And it depends on wind shear as part of what creates turbulence. The stronger the winds aloft, the weaker the winds at the surface. You're creating a circulation here, and it's turbulent. Looking across, when you're going across a rough field, for example, with a west, we'll say a west to east wind, in the plains again is a good example. Down in Florida, if you've got those sea breezes coming in, you got turbulence right along the leading edge of that sea breeze every time. Now, you get back in over the ocean, away from that sea breeze, you probably lost that turbulence. Mountains. Lots of turbulence around mountains. Anytime the bigger the mountain chain, the more the turbulence. Especially, remember which direction the wind is coming from over the mountain that day. It is going to impact how your flight plan works. We'll take the Rockies, and I want to take it at Denver. If I have a west wind at Denver, that means the wind is coming down the mountain into Denver. So what is going on there is your wind is sinking. Well, we know gravity picks up the speed of that wind because it's going to help to pull it down towards the ground. So what you wind up with is wind moving even faster as it's hitting into Denver and coming out into the plains. Now, if you go just above that layer of wind that came down over the mountain, you probably might have some much less wind. So there's going to be a mountain wave setup, a turbulent pattern there. If you were flying into the valleys, the same. And at the peak, on the downwind side, it'll be the worst turbulence. That's where the heaviest mountain waves are going to be. So as you're flying towards the west into the mountains, if there's a west wind, the turbulence is going to pick up. So you have to make that decision as the pilot. How comfortable are you with that turbulence? Because it's going to increase until you get to the other side of that mountain, where it'll begin to go down again. The same happens in the Appalachians. You can look many days when you're flying through a low deck of a deck of Q. There was a whole bunch of cumulus clouds on a flight I had. It was a small propeller aircraft. It was a long time ago. I was literally flying from Dulles Airport to Harrisburg, Pennsylvania, that time MDT, Middletown. There was a lot of Q out there. It was a small aircraft too. It was commercial. And I could tell you, as we were going to fly along, if we hit into that layer where the Q were, or just below it, I was going to have turbulence. I was going to bounce. And I did. Once we went above the cumulus, though, and it didn't have to be more than 1,000 feet, we flattened out, and I didn't have any turbulence whatsoever. So you can literally watch a line of clouds like that and see that. There always is going to be turbulence along the front because of the change of wind direction. There's obviously turbulence when a bigger aircraft is taking off, wake turbulence. And we've talked a lot about thunderstorms and all the turbulence with them, basically just staying away from them. There's clear air turbulence. This is a little harder to understand. We're going to take a look in a minute at a jet stream. The stronger the jet stream is, and we'll say right here, for example, where it's curved. Okay, here the winds are slowing down to make the curve because all that momentum just can't make that curve that quick, and they're picking up on the other side. So there's a lot of turbulence that goes right in here at the base of the trough, wherever that might be. So you would expect a lot of turbulence in that area. When you're in it flying along at 300 millibars and you have a jet streak, along the edge of that jet streak, you might have a lot more turbulence than maybe in the middle of it. So once you know where these are, you can anticipate what kind of flight you are. And I know most companies employ firms to predict the best flight path for them and all that. And part of it you're going to want to be. If you're flying today from Dallas to New York City, well, I want to be in this higher wind speeds, obviously. I'm saving fuel. I'm getting there quicker. But I don't want to be where it's turbulent either. So maybe I'm watching where I am in terms of relations to this jet stream today. I know when I fly across the jet, I know the jet is there. I've looked at the meteorology of it. I know if I'm flying across it. I can tell you where I'm going into the turbulence and where I'm going to come back out of it, depending on how I'm crossing that jet stream. So all of these are things you've got to be aware of as pilots. Hope you got a little bit out of this, and please don't hesitate to ask me any questions.